Question number 5. This question is from probability. Yasmin throws two ordinary fair six-sided dice at the same time and notes the numbers on the uppermost faces. The events A and B are defined as follows. Event A is the sum of two numbers is less than 6. Event B is the difference between the two numbers is at most 2. Sum of two numbers is less than 6 means x is less than 6. At most 2 means x is less than or equal to 2. There are two ordinary fair six-sided dice. These are the events. Event A sum of two numbers is less than 6. Event B is difference between the two numbers is at most 2. 2 are less than 2. This is called at most 2. Determine whether or not the events A and B are independent. First of all, we will draw possibility diagrams for both events A and B to have all the possible outcomes. We will draw first the two possibility diagrams for events A and B. Look at this. This diagram is for event A. Numbers on die 1, 1, 2, 3, 4, 5, 6. Numbers on die 2, 1, 2, 3, 4, 5, 6. Now we will find the outcomes by adding the two numbers 1 plus 1, 2, 1 plus 2, 3, 1 plus 3, 4, 1 plus 4, 5, 1 plus 5, 6, and 1 plus 6, 7. In the same way, we will find 2 plus 1, 3, 2 plus 2, 4, and so on. These numbers are the possible outcomes for event A. 2, 3, 4, 5, 6, 7, and so on. These numbers are the possible outcomes for event A. In the same way, event B is the difference between the two numbers is at most 2. So, die 1, this is die 2. We are making this possibility diagrams to have all the possible outcomes minus because we have to subtract the uh, numbers on die 1 and die 2. Die 1 numbering 1, 2, 3, 4, 5, 6. Die 2 1, 2, 3, 4, 5, 6. Now we will find the difference. 1 minus 1 that is 0. 1 2 difference 1. 1 3 difference 2. 1 4 difference 3. 1 5 difference 4. 1 6 difference 5 and so on. The same way 2 1 difference 1. 2 1 difference 1. 2 1 difference 1 and 2 2 difference 0. 2 3 difference 1 and so on. These are the outcomes, possible outcomes for event B. Now we have to show that determine whether the or not the events A and B are independent. First, we will find this is a relation between A and B. This is formula for the independent events. For independent events, the probability of event A intersection B is equal to probability of A into probability of B. This is formula to find to determine whether the events A and B are independent or not. If left hand side is equal to the right hand side, then the events A and B are independent. Otherwise, not independent. If not equal, then not independent. So this means that we have to find first probability of event A and probability of event B and probability of A intersection B. The intersection means and in statistics intersection means and probability of A and B. So first we have to find PA, PB and PA intersection B. Now probability of event A is equal to event A is sum of two numbers is less than 6. This is event A, these are the outcomes. Sum is less than 6. So we can take only these values 2, 3, 4, 5, 3, 4, 5, 4, 5, 5. So one possible outcome sum less than 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So probability of event A is 10 over 36. Similarly, we will find the probability of event B. Here 10 is the successful outcomes and total outcome 36. These numbers are 36. Now probability of B. These are the outcomes. These are the outcomes. Successful outcomes for event B. Uh, Total outcomes. Now successful outcomes. Event B is the difference between the two numbers is at most 2. At most 2 means 2 are less than 2. So we we can take only these values. Some difference is less than or equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So successful outcomes are 24, total outcome 36. So probability of event B is 24 over 36. Now we will find the probability of A intersection B. Probability of A intersection B mean sum is intersection mean and intersection of event A and B mean sum is less than 6 and difference at most 2. Sum less than 6, sum less than 6 and difference less than or equal to 2. So sum we will take help from this diagram. Sum is less than 6, we can take only these numbers 2, 3, 4, 5, 3, 4, 5, 4, 5, 5. These are the numbers in which these sums are less than 6. Now we will check if the difference is less than or equal to 2 because we have to take the difference. Event B is the difference between the two numbers is at most 2. So sum is less than 6 in these numbers. Now we will check the difference. So 1 minus 1 0. So we are taking this 1 minus 1 0, 2 minus 1 1. We are taking these numbers 3 minus 1 2, 4 minus 1 3. We will not take this because sum exceeds 2. Difference exceeds 2. So 2 3 4. We are taking 1 2 3. The difference less than or equal to 2. Now 2 minus 1 1, difference is 1. We are taking 2 minus 2 0. We are taking 2 3 minus 2, that is 1. We are taking this in the same way 3 minus 2 1. We will take 3 minus 3 0, 4 minus 3 1. In the same way 4 minus 1 3 we are not taking because it exceeds 2. So these are the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, 1, 2, 3, 4, 5, 6, 7. So these are the numbers in which the difference is less than or equal to 1, 2, 3, 4, 5, 6, 7, and 8. So these are the numbers whose sum is less than 6 and difference is less than or equal to 2. These are 8. So we write here probability of A intersection B is equal to 8 over 36. Now we will apply the formula of independent events. Formula for independent event is probability of A intersection B is equal to probability of A multiplied by probability of B. Now putting the values here, probability of A intersection B is 8 over 36. We write here 8 over 36 is equal to PA, probability of event A is 10 over 36. Probability of event B is 24 over 36. So clearly, left hand side uh, is not equal to right hand side. Left hand side is not equal to right hand side. You can check by your calculator. So since the left hand side is not equal to a right hand side, we can say that event A and B are not independent. So we will write that event A and B are, this shows that event A and B are not independent. Now next part of this question is of conditional probability. Find probability of B given that A dash. Probability of B given that A dash. So this is general formula for conditional probability. This is formula for conditional probability. For two events A and B, for two events A and B, probability of event A given B is equal to probability of A intersection B over probability of B. This is general formula for conditional probability. Now, in the question, we have to find the probability of event B given A dash. A dash is a complement of A, so we will, according to the question, we will use this formula to find conditional probability. Probability of B given A dash will be equal to, according to the formula, probability of B intersection A dash over probability of A dash. First of all, we settle down this probability of A dash, which is in the denominator. Clearly, probability of A in the above part we have found 10 over 36. Now, probability of A dash is a complement of A. So, we can write it as denominator will be 1 minus probability of A dash will be 1 minus 10 over probability of A. Probability of A is 10 over 36. So we write here 1 minus 10 over 36. This will be the probability of P A dash. Now we find probability of B intersection A dash. Now intersection means and. B intersection A dash means difference is less than or equal to 2 and sum difference is less than or equal to 2 and sum is greater than or equal to 6. So we will take help from here from the diagram. We will take help from the diagram. Now sum is greater than P A dash means sum is greater than or equal to 6 and difference is less than or equal to B is the event that the difference of the two numbers is at most 2 mean less than or equal to 2 and A dash mean even A is the numbers less than 6 but A dash will be the greater than or equal to 6. Greater than or equal to 6. This is for the A dash. So we will take help from this diagram. Sum is greater than or equal to 6 lies here. So these are sum is greater than or equal to 6 and the difference less than or equal to 2. So these are the numbers. So we are taking these numbers 6. Here the sum is 6 and difference is 4, 2. 4 minus 2 that is 2. So accepting next this number sum is 6 and difference is 3 minus 3 0. We are taking this number. We are also taking this number 8 again 6 7 8 9 10. Next is 8 9, 10, 11, 10, 11, 12. These are the numbers which uh, which covers the B intersection A dash. That sum is greater than, clearly sum is greater than 6, greater than or equal to 6, but difference is less than or equal to 2. These are the numbers. So these numbers are 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So we will write that probability of B intersection A dash probability is 16 over 36. So we write here 16 over 36. Now simplifying it, the numerator is 16 over 36, denominator is 26 over 36, cancellation. So we get 16 over 26, that is equal to 8 over 13. So we will write the answer and correct to three significant figures. So final answer is 0.615. This is the final answer.